The ocean covers more than 70% of our planet. And yet we know more about the surface of Mars than we do about many of its depths, which means that beneath those dark waters live creatures so strange that if we saw them in a movie, we would probably assume they were pure science fiction. Today we're looking at two of them. One has 3 hearts, blue blood, and a nervous system spread across 8 arms that can make decisions almost on its own. The other has survived for more than 400 million years, outlasting mass extinctions, climate shifts, and entire eras of life on Earth. One looks like it was designed by an alien engineer who got bored and decided to experiment. The other was turned into a villain by a dramatic soundtrack. But when you look closely, you start to realize something important. The ocean is not filled with monsters. It's filled with intelligence, adaptation, and balance. And by the end of this video, you might start to wonder if the real misunderstanding was never in the water, but in the way we chose to tell the story. The octopus does not look like it belongs on this planet, and that's not an exaggeration. It has 3 hearts. 2 pump blood to the gills and 1 to the rest of the body. But when it swims quickly, that main heart can actually stop beating for a few seconds, almost as if its own system decides to conserve energy instead of overworking itself. And its blood isn't red, it's blue because instead of using iron to transport oxygen, it uses copper, which allows it to survive in cold, low-oxygen environments where many other animals simply couldn't function. Even from a biological standpoint, it's unusual, but the truly fascinating part begins when you realize it has no bones at all. Absolutely none. Its body is essentially muscle and neurons, and if its beak, the only hard part it has, can fit through a small opening, the rest of the body will simply flow through behind it. That means it can escape from almost anywhere, and it has. There are documented cases of octopuses leaving their aquarium tanks at night, sliding across the floor, and returning to the ocean as if they were carrying out a carefully planned secret mission. But flexibility isn't the most unsettling thing about it. It's intelligence. An octopus has around 500 million neurons, a number comparable to many vertebrates. But what makes this truly remarkable is that much of its nervous system isn't centralized in a single brain. Instead, it's distributed throughout its arms, meaning each arm can process information and make decisions almost independently. It's decentralized intelligence, something we are still trying to replicate in modern technology. In laboratory experiments, octopuses have solved complex mazes, opened jars from the inside, used tools, learned by observation, and remembered solutions for weeks. And they can even recognize individual humans, clearly distinguishing between those they prefer and those they don't. Then there's camouflage. An octopus can change color in milliseconds, but it doesn't stop there. It can also alter the texture of its skin, becoming rough like rock or smooth like sand, perfectly matching patterns in its surroundings with astonishing precision. What makes this even more incredible is that octopuses are colorblind. They don't perceive color the way we do, yet they reproduce it flawlessly, which suggests they interpret light and their environment in ways we still don't fully understand. Some species can even imitate the movement and shape of other marine animals, transforming themselves into what looks like sea snakes or venomous fish when necessary. But there is also a tragic side to their story. After reproduction, many octopus species enter an irreversible biological decline. They stop eating, their bodies begin to deteriorate, and it's as if their genetic programming signals that their life cycle has been completed with absolute precision. They are intelligent, flexible, complex, mysterious. If there were ever a creature that feels as though it was designed somewhere beyond our world, it would be the octopus. The octopus shows us that intelligence doesn't have to follow a familiar blueprint, that evolution can build a mind without bones, a body without limits, and a system so decentralized it almost feels futuristic. It is flexibility, strategy, and mystery wrapped into one soft, shifting shape. But if the octopus represents ingenuity and alien-like complexity, then the shark represents something entirely different. It represents endurance. It represents evolutionary precision. Because while the octopus surprises us with camouflage and distributed neurons, the shark has been there for hundreds of millions of years, watching oceans rise and fall, adapting quietly, surviving when countless other species disappeared. And this is where the tone shifts. Because the next creature doesn't need to hide among rocks or change colors to command attention. Its very presence demands respect. The shark is not the villain we were sold, even though for decades, cinema carefully built that image with dramatic music and slow-motion shots of sharp teeth. Because if Hollywood knows how to do one thing, it's turning almost anything into a monster, even a fish that is simply doing its job in the ocean. The truth is far less cinematic and far more interesting, because the odds of a shark attacking a human are extremely low. So low that statistically, you are more likely to be hit by a falling coconut than experience a real shark attack. Yet somehow nobody swims in tropical beaches, nervously looking up at palm trees, and the shark still carries all the blame. Most shark species are not even dangerous to humans. Many are small, others are shy, some rarely even enter areas where people swim. But once the narrative was written, it became difficult to rewrite. Now, if we put fear aside for a moment and look at sharks through the lens of biology and evolution, what we find is one of the most impressive survival stories on Earth, because sharks have existed for more than 400 million years. They appeared long before dinosaurs, long before modern trees, long before many life forms we consider ancient today. And they didn't just survive the passage of time, they survived 5 mass extinctions that wiped out much of life on the planet. That is not luck. That is extreme adaptation. Their bodies are engineered for efficiency, their skeletons are made of cartilage instead of bone, making them lighter and more flexible, allowing for powerful yet agile movement through water. And their teeth are not a limited resource. A shark can lose thousands over its lifetime and continuously replace them with new rows ready to move forward like a biological conveyor belt that never shuts down. But here is where it starts to sound like science fiction. Every living organism produces tiny electrical signals when the heart beats or muscles contract. Even when we are perfectly still, and sharks possess specialized organs called the ampullae of Lorenzini that allow them to detect those electrical fields in the water, even in total darkness or when prey is buried beneath sand. They don't need to see you. They can sense your heartbeat. They are quite literally living biological radar systems. And as if that were not impressive enough, some shark species are bioluminescent, emitting a soft glow in the depths of the ocean, using light for communication or camouflage in an environment where darkness dominates and illumination becomes a strategic advantage. Now comes the uncomfortable part of the story. Every year, humans kill tens of millions of sharks, primarily for the fin trade and commercial fishing. Wild deaths caused by sharks are extremely rare by comparison, which means the real imbalance does not flow from the ocean toward us, but the other way around. Sharks play a crucial role in marine ecosystems, regulating populations, removing weak or sick individuals, maintaining balance within food chains, and helping coral reefs and other marine communities remain stable. And when shark populations decline, the consequences are not small or isolated. They create cascading effects that disrupt entire systems. They are not monsters built for chaos. They are keystone species in an ecological machine that has been running for millions of years. Maybe the shark was never the villain. Maybe it was simply easier to fear it than to understand it. The octopus reminds us that intelligence can evolve in unexpected forms, that complexity does not require a backbone, and that some of the most extraordinary minds on Earth move silently beneath the waves. The shark teaches us something different, that survival across hundreds of millions of years is not about aggression, but about balance, adaptation, and occupying a precise role within a vast and interconnected system. One seems alien, the other seems terrifying, but neither is what we were taught to believe. The ocean is not a horror scene. It is a living laboratory of evolution that has been running long before we ever arrived. And the more we understand it, the clearer it becomes that these creatures were never the problem. Our perspective was. If something in this story surprised you, consider subscribing, because the world is far stranger, more complex, and far more fascinating than it first appears.